Hello there, Chem 2. We're going to talk about Chapter 10 review today. We're going to discuss the mole, which remember is basically just Avogadro's number, 6.02 times 10 to the 23rd of whatever. We're going to discuss molar mass in these videos. We're going to discuss percent composition. So that's like sodium sulfate. We have 2 sodium, 1 sulfur, 4 oxygen, and we will break that down into its percentages. So sodium would be 32.3%, sulfur 22.5%, oxygen 45%, and we're going to show how we can get that. That will be a review. Empirical formula. So here on the empirical formula you can have a molecule like C2H6 ethane, and we can break down or reduce the subscripts to C1H3, and so that is the empirical formula. And then we're also going to discuss molecular formula and how you find it. So back up here with the ethane molecule, the C2H6 would be the molecular formula. So, and back on molar mass, you should know that oxygen, you look on the periodic table and its molar mass would be 16 grams per mole. So the first thing we will discuss is the mole and Avogadro's number. So that's the first review we'll have. Okay, so the review of the mole, chapter 10. Remember, a mole of something is just 6.02 times 10 to the 23rd of that thing. So we can discuss particles, discuss atoms, molecules, ions, can be any number of those. It's just like a dozen. So a dozen equals 12 of something. A mole equals 6.02 times 10 to the 23rd of something, and the things we're talking about again are listed here. The two types of problems that we can have with this is going from atoms to mole and mole to atoms. We're going to do both of these types of problems today, and just remember this, make sure you write this in your notes. This is Avogadro's number. This is review, but you should know that. Alright, so let's do mole to particles, or mole to atoms, or mole to ions, mole to molecules. It's all going to be the same thing. Let's do this type of problem first. So we have here how many particles. I wrote in particles at first. It could also be atoms. So how many atoms are in 4.65 mole of silicon? Does it matter what type of element we have? No, because we're just asking how many atoms in this many mole, and so we're just going to use the ratio that I just showed you. 1 mole equals 6.02 times 10 to the 23rd of something. And this something is atoms this time. So how to distinguish between going from mole to atoms or atoms to mole in the word problem is they give you 4.65 mole. They give you that. So that's what you have to start with. So let's start doing our math here. Let's do the railroad track. 4.65 mole. And it's silicon. We need to convert that to atoms. So we're going to have to use a ratio. In our multiplication here, on top we're going to want atoms, and on bottom we want to cancel out the mole of silicon, so we'll put mole I here, and we go back to our ratio. 1 mole goes to 6.02 times 10 to the 23rd atoms. So 6.02 times 10 to the 23rd goes up top, and the 1 goes with the mole. So we're going to cancel mole silicon out, and we go to our handy dandy calculator here. And we'll do 4.65 times, and I'll have to use my parentheses, 6.02 times 10 to the 23rd, and that gives us 2.7993 times 10 to the 24th atoms of silicon. Let's write that in there. So let's do 3 sig figs. So we round up, and that's going to be 2.80. Because this 9 makes this 9 go to 10, so that makes that go to 8. So 2.80 times 10 to the, I don't know if you can see that, but it's times 10 to the 24th atoms of silicon. So, yeah, I don't know if you can see that. Times 10 to the 24th is our answer. Okay, so that's mole to atoms, or any other particle, or anything you want. We could go moles to number of cheetahs if we wanted to, if we were given moles of cheetahs. Alright, so let's go to particle, molecule, atom, or ion, one of these 2 mole. And again, here's the problem. How many moles are in 4.65 times 10 to the 24th atoms of nitrogen? This is what they give you. They give you the atoms. So that's what you have to start with in your railroad track. So let's write in 4.65 times 10 to the 24th atoms. I'll put an N for nitrogen. We'll start doing our railroad track. Okay, so again we go back to our ratio that we always know. 1 mole equals 6.02 times 10 to the 23rd of atoms in this case. So let's work with that. So I want atoms on the bottom, and we want mole on top. So we'll put the ratio 6.02 times 10 to the 23rd, 1 mole of nitrogen will give us, let's put this in our calculator, 4.65 times 10 to the 24th. Oh, I didn't use parentheses, so I'll hit equal sign. Now I'm going to multiply that by the 1, I guess. 1's on top here. Now I'm going to divide by 6.02. 10 to the, and bam, we get 7.72 mole. And remember, cancel out my units there, mole of nitrogen, 7.72 mole nitrogen is our answer. And remember, moles are going to be small numbers, so 7.72 is not a big number compared to the number of atoms we'll have. Atoms will be huge, as times 10 to the 24th, and that makes sense because there's a lot of atoms in all around us. But the moles are counting by big units, so it's going to be a small number. Okay, so that's the first part of the review. Moles to atoms, atoms to moles.